A wonderful subscriber asked me to compare the multivariate section of Pugh and Munkres' analysis of manifolds. But I really, and I was going to do that. I actually started writing up I started writing up a list of topics in Pugh. This is your standard fare for multivariate analysis, R to the n, otherwise known as. And I was going to map it to Munkres, but of course it maps to the entire book. But then I decided, no, this is an interesting question, but actually the broader question is the one that I'm interested in answering, of course, for myself, because someday, God willing, I plan to get back to analysis, which I totally, as you all know, love. And you will see many, many videos about analysis in my channel already, including my 17 months of analysis video. And so I think when my return to analysis will have to be prefaced by an entire sequence of differential geometry, and then I will land in R to the n. So in this video, I'm going to talk about, return to R to the n. What is that for me? And I'll make it in parts because I want to go about it sequentially. And these days I can actually combine videos. So this little bit is only laying out what I'm going to do. I'm going to lay out the sequence of events that I would plan to follow to do R to the n, and Pugh would only be part of that entire broader thing. So I'm not going to get started with the beginning phase of how I would do it. I'm going to talk about the actual ask for what I was asked to do as a recommendation, and I like it, but I'm going to broaden it. But I still want to begin by saying, okay, Pugh and Munkres, sure. So if I was only doing these two books, I think I would do Pugh first, just because it'll give me like a broad coverage, and I think the coverage is broad, but it doesn't have as much content as Munkres. So I would probably start with Pugh. But really, as I said in the intro part of this video, I would cover this entire book, O'Neill, on elementary geometry, just because I would like to know how manifolds work, all the various laws that have to do with differential geometry. So, and I've discussed this book before, but yeah, I would also, and I didn't include it in this group, but I would be looking back at point set topology as well. But really, I would focus on this book. I'm not sure if I would cover the entire book, but I would definitely try to get enough so that when I go into Pugh, I have an understanding of what Pugh is talking about. So let me just go through the topics, because these topics are the ones that I'm going to go through in all these different books. So, of course, there's the art in one dimension. Pugh does your topology chapter the same as Baby Rudin does. And then you would be in here. You would be in multivariate calculus. Now, of course, the difference between all these books, of course, is that when you land, say, in chapter 5, you have to assume, the author assumes that you already read before. So I don't know. I would have to do a little bit of a reading of the early chapters of Pugh, maybe do a few problems as well, just to get into how the book works. Maybe I would even cover the whole book. Yeah. But then what does Pugh cover? He covers linear algebra, derivatives, then R to the n derivatives, implicit function theorem, and inverse function theorem, the rank theorem, Lagrange multipliers, and he goes into multiple integrals. Then he gets into the meat of the thing for Stokes' formula with differential forms. And he does do a little bit of history and a little bit of context, which I really like about this book. So if we jump to page 277, okay, I'll just page through briefly so you can see how the book covers it. So yeah, let's just say by this time, I would have refreshed my memory of what I did the last time with Wade. I would have done some reading, but before that, of course, as I said, I would have covered differential geometry. So I would have done differential geometry, then gone and read a little bit in Wade, because one thing that I noticed that's the difference between Wade and Pugh for R to the n is there's just more baby stuff that I think I would need. And of course, I'm familiar with Wade because I already read the whole book once upon a time and even did problems for most of the chapters. But yeah, so you have linear algebra using the linear transformations, which I like because it ties into all the linear algebra that I've been doing recently. And then, of course, I really love the way this is laid out. In the world of finite dimensional normed spaces, all linear transformations are continuous and all isomorphisms are homeomorphisms. And then there's some particularity about it. So yeah, I would do this, but then after covering the entire chapter of Pugh for R to the N, I would get more, a lot more, because everything that is mentioned here, Fubini's theorem, Lagrange multipliers, change of variables, the Jacobian, all that is mentioned in a lot more detail in Munkres. So yes, I would cover Pugh, but then move on to Munkres. And the entire book for Munkres covers what Pugh did in just one chapter. Okay. Now, the one thing about Munkres that I noticed, that I've noticed before when I've talked about the book, is it has examples, but it really does feel like typed up notes. I think it doesn't feel like if the wording is, it doesn't have enough wording for a baby like me. But yeah, I would, so by this time, let's just go through the sequence. And actually, I think I want to write it down. Okay, I would have done, maybe I would start with Wade just to go to home base, basically, if you want to use the analogy for baseball. Then I would have done O'Neill, okay, enough of it for differential geometry. Without maybe this would have been after I did more differential geometry before. I'm not sure, but let's just say I'm returning to R to the N. So I would do that. And then, of course, so I've already done O'Neill. I've already done Wade, revisited all the topics in Wade. So I've already covered all the material. Then I would do Pugh's chapter, okay? Perhaps do the whole book, I'm not sure, but let's just say it's only R to the N being the subject. And then now we're in Munkres, okay? Now we're in Munkres. And of course, all along, I have at my disposal other books, okay? Such as Baby Rudin, especially for chapter 10 and chapter 9. You see here the usual suspects, right? We just talked about them. So inverse function theorem, implicit function theorem, rank theorem, the use of linear algebra, and then, of course, the integration of differential forms, getting all the way down to Stokes' theorem. So there is something that I would cover in Baby Rudin when I would do this. But of course, also, there's two other books that I would use just to kind of like use as references, particularly for differentiation in R to the N. I do think that I would want to cover this book, at least the chapter on R to the N, because I know that it's just a lot that gets covered in detail with lots of problems. So I'm pretty sure that I would go over, just as a reference, I'm not sure if covering it in detail, these two chapters in Thomson, Bruckner. And then, of course, Porter and Murray would also be a reference that I would use, because it's got a lot of R to the N. And I know that when I first went through this material, that I did. So I would go back, and every now and then, implicit function theorem and Lagrange multipliers, I would go and read in Porter and Murray, because I did like just the way Porter and Murray discussed this material. Boy, I'm having problems saying that name. So yeah, so I would, my process would culminate with Munkres. So really, to answer the question that was specific to start this idea for this video, when I compare Pugh and Munkres, I want to do Pugh first, but I also want to do Munkres. And I've said this in various videos that I've made before. Usually I'm asked the question of A or B, right? Which one is better? And sometimes I can answer that question. So for example, so when people say to me, what would you do for your very first analysis book? Okay. And I always say Bardo and Sherbert. Okay. And then of course, Wade is somewhere in here. By the way, I didn't show Bardo and Sherbert because Bardo and Sherbert doesn't have any R to the N content. But then my final course, maybe there would be a dessert in here, but my final main course, if I compared between Pugh and Munkres, would be both, okay? But I would do Pugh first with things before it, and then I would spend a lot of time going through all of Munkres. I would actually cover this entire book in detail and try to do as many problems as possible. And so if we go through it, and of course I have videos for this book, a video for this book elsewhere on my channel, so I'm not going to go through it in gory detail. But if you look at the table of contents, you will see that it very much maps, okay, to the content that we found in Pugh. Although I really do like the whole way with linear algebra that Pugh starts. He's got some historical at the end. So yeah, I mean, Pugh is a great book, I think. But this is also a great book. So this is why it's always, usually my answer to these questions is A and B, finding a way to complement them, finding the way to do them all at the same time. So sure enough, your topology fair, differentiation, integration, change of variables, manifolds, of which there is a chapter in Wade, and of course there is some content in Pugh, and then differential forms, getting down to Stokes' theorem. And I'll end there.